Here we have cardinality rules. The first one is for 2 sets. The other one is for 3 sets. So this is number of elements inside A or B. So that is for or. That is equal to number of elements inside A plus what you have inside B minus subtract those members that are in common between A and B. When you have disjoint sets, meaning you don't have any members in common between 2 sets, in that case, number of elements that are inside A and B is empty set. We don't have nothing on that part when you have disjoint sets. So for disjoint, sets, to find this part, you only need to add number of elements in A plus number of elements in B. And that's it. Now for 3 sets, number of elements in A or B or C is equal to, first you have to add all these 3 sets, the numbers that you have, how many members you have in each one, add those first, and then subtract what you have in common between pairs, and finally add the intersection between all these 3 sets. So first we have addition between 3 sets individually, and then subtract what you have in common between pairs, and finally add the intersection between 3 sets. Now example number 1, Dunkin' Donuts collected the following information regarding purchases from 100 of its customers. We have 65 purchased coffee, 41 purchased donuts, 22 purchased both coffee and donuts. Part A, how many of those surveyed purchased only coffee? I'm going to again write what is given. I'm going to use C for coffee and D for donuts. So let's see, equal to coffee and D for donuts. Now what is given? We have 65 coffee. The number of elements for coffee are equal to 65. 41 donuts. And 22 purchased both coffee and donuts. So that is the intersection between C and D is 22. And also what is given on top, it says they had 100 customers, meaning that that is total. So it's universal set. Now I want to see what is asking. Part A, how many of those surveyed purchased only coffee? So here we have to find number of elements that we have, coffee, subtract the intersection between C and D because it's asking for only. So what is this one? And part B is how many of those surveyed purchased only donuts? So it's the same. but I have to use number of elements in D minus subtract the intersection. Let's work on these two. It's better to always draw a diagram. So this one is for coffee, this one for donut. First, starting with what you have in common is 22 here inside, between. So we did that part. Now, number of elements that are in D. Total, we have 41, but I want to find what is left. So for that part, we have 41 minus 22. So it's 19. Now for C, total we have 65. So 65 minus, but we already have 22 here. So the answer is 43. So that part is 43. Now, based on what I have here, part A, it's only C. What is the answer for B? Only donut, we have 19. And now, part C, how many of those surveyed purchased neither of these items? I'm going to write that one here. Here for part C, we have to find number of elements. That are inside complement of C union D. So this is the way that we have to write. So this is for part C. And this one is equal to number of elements in universal set minus number of elements in C union D. So that is equal to 100. We have 100 customers total minus C union D. We have to add all these three numbers. Is 43 plus 22 plus 19. I'm going to write this one first because we used only C, only D. So for this part, we have to add only C plus what we have in common between C and D. And add only D. It's 100 minus 43 plus 22 plus 19. 100 minus 84. So the answer is 16. Now I'm going to use this rule that we had on top, Cardinati rules, to find the answer for C. So another method. This one again for part C. using cardinality rule. First, we have to find number of elements in C union D. That is equal to number of elements in C plus number of elements in D minus number of elements in intersection part. So this one is equal to 84. We have, how many we have inside C? Total we have 65, that was given. How many we have for donuts? We have 41, this part also was given. The intersection part was given. See, I'm working based on what was given here on this part. 65, 41, 22. So that is equal to 84. Now finding. So without drawing this Venn diagram, I'm able to find the answer for this part. So this is 100 minus 84. That is 16. But the only difference between the first method and the second one, cardinality rule, was that I didn't try to find only C, only D. Example number 2 in a survey. Here we have total is 92. Was found that 27 had a spa and 55 had fitness center, 38 had children's club. And we have 13 had a spa and fitness center. So this is the intersection between spa and fitness center. Intersection between spa and children's club is 10. And here we have 19. And 7 is between all three. So based on what we have here, we have to answer A, B, C, D, E. So let S equal to spa, F fitness center, and C is children's club. Now writing all that is given, number of elements. Okay, what we have in total is 92, so that is universal set. Number of members for SPA is 27. For F is 55. For C is 38. Now what we have in intersection part? S and F. (13) S and C. 10. F and C is 19. And finally, all these three is 7. So first, I'm going to draw a Venn diagram. Okay, so we have 3 sets. This one is spa, this one is fitness center, and here is children's club. First, we have to start with what we have in common between 3 sets. So writing this one inside is 7. Now the intersection part between F and C, total we have 19 members. But we already have 7 here between F and C. It's 19 minus 7, remaining is 12. Next one, do same thing. Between S and C, we have 10, but we already have 7 here inside. What I should have here on this part. Next one, S and F is 13. We already have 7. So we should have 6. Total is 13. 7 plus 6 is 13 between S and F. Now we have to find the remainder for F. So for F, here total we have 7 plus 6 plus 12. We have 25, but we should have 55. I'm going to write that part here to explain. So for F, we had 6 plus 7 plus 12, and it should have something else here. Do the same thing for S and C. For S, we have 6 plus 7 plus 3 is 16. But here we have 27. So 27 minus 16. Remainder is. Finally, for children's club, 7 plus 3. So this one, 7 plus 3 plus 12. We have 22, but we should have 38. So that is 16. So I'm going to add all these numbers. Plus 30, plus 12, plus 16. Here we have total members here inside these 3 sets. We have to subtract that one with what we had in total is 92. So 92 minus 85, that is equal to 7. This number is what we have outside these 3 sets. So everything except S, F, and C. Now let's answer these based on what we have here. A, only spa. How many of these are inside only spa? Only spa is just this one. And that is 11. Exactly one of these features. So exactly one of these features, that means you should add only S, only F, only C. So adding all these numbers, these 3 numbers. it's equal to 57 for part B. Part C, at least one of these features. So we can have 1, 2, or 3 of these features because it says at least one. That means we can have only one, which is 11, 30, 16. Or we can have 2, F and S, F and C, S and C, so having 3, 6, and 12. Or we can have all these 3 features, which is 7, the number that we have in common between all these 3 features. So at least one, either 1, 11, or 2 of these. We have 3, 6, 12, or all of these 3 features. 7. So the answer is 85. Part D, exactly 2 of these features. Exactly 2. That means I should add F and S, S and C, C and F. So F and S we have 6 in common. S and C we have 3 in common. And C, F we have 12 in common. So that is equal to 21. None of these features, part E. So what we have outside these circles, that is the answer for part E. So we can add all these numbers and find complement of these 3 circles. So we have S union F union C, complement of these 3. We can use number of elements that we have in universal set minus number of elements that we have in these 3 circles. These groups, here we have S, F, C. So total what we have in the survey, we have 92. That is our universal, and subtracting what we had in part C, which was at least one of these features. So that is 85. This is total numbers that we have in these 3 groups. So 92 minus 85, our answer is 7 for part E. These are our answers. Now in this part we have 356 on an iPad, 293 on laptop, 285 on gaming system, 193 on iPad and laptop, 200 on iPad and gaming system, 139 on laptop and gaming system, 68 on laptop, iPad, gaming system, 26 on none of these. So I'm going to use I for iPad, L for laptop, G for gaming system. And what is given, we have number of elements in I, or how many iPads? It's 356. And what we have for laptop, it's 293. And for gaming system, we have 285. Now here we have 193 iPad and laptop. So iPad intersection, laptop, that is 193. Then we have iPad, gaming system, that is 200. Laptop, gaming system is 139. Then we have all these three, iPad, laptop, gaming system, we have 68. And none of these. Complement of all these three, that is equal to 26. I'm going to draw a Venn diagram. So this rectangle is universal. So this one for iPad, here for laptop, and this one for gaming system. So before working on these part A, B, and C, first I'm going to find all the numbers that we have in these three circles and what we have outside these three groups. So starting with what we have in common between all these three groups, we have 68. And then what we have for iPad, laptop, here we have intersection part is 193, but the point is that we already have the 68 between these two. So we should subtract this part to find the answer for that part. So for that one, I'm going to use what we have in common between I and L. It's 193 minus the intersection between. So because we already have this number here on that part. Here is 125. So for this part, we have 125. Then what we have in common between iPad and gaming system, we have 200, so we use that number. Again, subtracting what we had in common between all these three is 68. So that is equal to 132. This is what we have for this part. So between I and G, we have 132 plus 68, total is 200. And then this part, we try to find this one. Between L and G, we have 139, but we already have 68 here, so subtract 68 from 139 to find the answer for the rest of this part. So this is 71. And now we have to find what we have for this part. Only I, only L, only G. To find the answer for only I, here we have, for I we have 356 total. But we already have 125, 68, 132. So we should subtract these from 356. So 356 minus 125 plus 68 plus 132. So adding all these three numbers, subtract from what we have totaling for our iPad. So here is 31. Then we have only laptop. For this one, total is 293 minus, we should subtract these three numbers again. What we have, well, what we already have in the circle for laptop, it's 125, 68, 71. So the answer is 29. And then we have only G. The answer for that part, for only G we have 285 minus G we already have 132, 68, 71, so subtract these three numbers. And the answer is 14. Now that we have all these three circles, all the numbers that we have in these three groups, we want to find what we have outside these three. So that is given. It says 26 owned none of these devices. So outside of these three, we have 26. Now answering these three questions. Part A, how many college students were surveyed? So part A, we can add all these numbers to find the answer for part A. It's 31, 29. So I'm starting with only iPad, only laptop, only gaming system. Then I have between I and L, we have 125, 132 for I and G, and for LG we have 71. And then between all these three devices we have 68. And what is outside, it's 26. And this is equal to 496. So that's the answer for what we have total number of elements in universal set. So all the numbers that we have in this rectangle. So the answer here is 496. Or use quadratic rule to find the answer for part A. So we have number of elements in all these three. That is equal to number of elements in I, L, G, minus number of elements in I and L minus number of elements in I and G minus L and G plus all these three. So what we have an intersection between all these three, I and L and G. So here we have 256 for number of elements in I. Then for L we have 293. For G we have 285. Now subtracting what we have in common between I and L. I and L, I and G, and L and G. So we have to subtract all these. So minus 200 minus 139. And then add what we have in common between all these three devices as 68. So the answer for this part is 470. So this is first step. Second step to find the answer for part A. So we have number of elements, all of these, with complement. So that is equal to what we have in universal set minus what we did in step 1. So here it doesn't matter if you write I, L first, or if you write L, I first, because here I have L, I, but here I have I, L, so these are the same. So in this part, this one was given. We have 26 is outside of these three devices. So here is 26 equal to, we're trying to find what we have in total number of elements in universal set minus step 1, 470. So we have 470 plus 26, the answer is 496. So again, same answer for part A. Now part B, how many of these students owned iPad and gaming system? We already have all these numbers, so it's easy to answer these questions. So here is iPad and gaming system. But not laptop. Because if it was iPad and gaming system, the answer is 132 plus 68, but here it says not laptop. So we're not able to have this number, this 68. So only these two devices. ING, that is 132. Then we have laptop, but neither an iPad nor gaming system. So laptop is this number 29? Because here it says, but neither iPad nor gaming system. So we cannot have these. But only what we have here for laptop, which is 29. So here the answer is 29.